BSides DC 2017 videos are brought to you by Threat Quotient, introducing the industry's first threat intelligence platform designed to enable threat operations and management, and Data Tribe, a new kind of startup studio co-building the next generation of commercial cybersecurity, analytics, and big data product companies.
Good afternoon. My name is Omer Farouk, and I work as ISC, Independent Security Evaluators in Baltimore. And we are a security assessment, security evaluation company based out of Baltimore, focusing on assessment of web applications and infrastructure in the cloud and web and mobile applications at the same time. I particularly have a background in cryptography and background in embedded software development. I've been doing security evaluations and security work for the last 5 years. Today's talk is about secure key management in the cloud, and so we'll get started. So this particular talk is divided into 4 different sections. Since we have a pretty large crowd, we'll probably start with a little bit about key management, talk about what key management and data encryption at rest or in storage means. Talk about HSMs a little bit, then talk about key management in the cloud and what we are talking about in terms of either native clouds, native cloud applications, or partner solutions, or custom applications hosted in the cloud. Then we're going to talk about some of the core stuff, which of this session, and which would be how to secure your native key managers in the cloud. And at the end, we will talk more specifically about some workflows, and those workflows are from media entertainment or graphic rendering. So there's a lot of compute, there's a lot of storage going on, and there's a lot of networking components. So pushing in or meshing in a key manager in there, it's quite interesting. So it gets all the flavors of most of the components that you find in any cloud platform. And at the end, we do have a vendor-specific, Azure-specific, or Microsoft Azure-specific reference architecture, talk about specific deployment hardening guides and things like that I have worked on. And I know there's a huge push, and AWS is a major player, so we do have an AWS reference architecture at the end also. What this talk really is about is securing key management in the cloud. And we want to make sure that I want to say up front that we are technology vendors agnostic. We're not pushing any specific technologies. We're not pushing specific vendors or cloud providers. That's not the point of this talk. Though there is some kind of reference architecture work in here, but it is pretty generic, and it can be adapted to any cloud platforms. Majority of you guys who've been working with cloud platforms know probably that all the components are pretty interchangeable with different names, and all these guidances can be applied pretty seamlessly. I just want to be upfront, disclaimer, that was what this talk doesn't talk about, or is not about any kind of deployment of PKI server or things like that, or compliance or regulation, or specific things about NIST or FIPS standard. This is more about technology implementing a key manager or using a key manager in the cloud. At the same time, the key management as a topic, is quite large, and I'm pretty sure that it can't be covered in 50 minutes. So we're going to specifically talk about key management and data encryption and how to encrypt data at rest specifically. But at the same time, I will refer out a lot of information here that can be used to store, to secure or use key managers for compute resources, like using key managers in your applications, or embedding how to make the API calls to run for specific purposes besides storage. So before we get started, I'd like to just start with a little bit about encryption and why encryption is very important and why we're talking about this today. So, given the recent data breaches and data and hacks in the news with Equifax or Home Depot or OPM and things like that, an industry-wide approach has been to protect data using encryption. And the idea that encrypt everything, use encryption to protect is something that's thrown out quite a bit. What really isn't talked about more isn't about the infrastructure that goes around protecting and having data encrypted along with it. So I want to start this conversation today with a little bit of, since we have we have a pretty diverse crowd here, talk about encryption first and how it works and what are the components involved, and then introduce key manager and key management into it. So a common method of, so you have data, you have tools like data encryption algorithms, and then you have keys. Those three things are used to protect plain text data. You take the tools and you apply keys and you scramble it with different algorithms, and then you have protected or ciphertext. How does that work? So one of the examples that we should actually introduce right up front is something called envelope encryption. This is quite common in a lot of cloud computing or web applications these days, where there's a lot of objects, where data and data keys for objects per object is stored along with the keys, with the data itself, and the keys along with it. And the way it works is that you have a user or you have an application which requests a data key or requests a master key to be created, and then you have some kind of cloud key manager or on-premise key manager that creates that key, which in different worlds is called CKM, which is customer master key, CMK, or master key or master secret. And then based on that, essentially the key manager will return you a data key, which is essentially a key that was generated that is internally generated by the KMS. Both the ciphertext and the plain text version of those keys are returned, and the user takes those keys to encrypt the data with the plain text version, and then stores the encrypted version along with the data itself into a storage of its choice. Either that could be back in the cloud or it could be back on premise. So this is a general idea of one way of how data encryption works at rest. So as you can see from this example, your key manager is quite involved in this. This key manager could be on location, on-prem, or it could be in the cloud, or it could be hosted in some kind of hosting site or whatever. Now, if the KMS is breached, and if an attacker can read all the data, read all the keys, they potentially can get all the data. So that's why protecting the key manager is pretty important. Another concept that's very, very, very important to understand, or I think we should go over, is key hierarchy. How key hierarchy works in data encryption, and how that is used quite prevalently into secure objects and data. So, like in the previous slide and the previous example, we talked about having key manager deriving keys and giving keys out based off a master key. What the key manager can also do is you can create keys, a data key, and then encrypt that with the master key, possibly, and then use multiple keys from that. It can create master data key, then it can encrypt the data key with the master key, and the master key it could be encrypted with a silver master key, and a silver master key could be encrypted with an N-level gold key. The idea over here is that key managers are used to protect data at object level, possibly at region, depending on how you have your environment set up or how your workflow works. You can encrypt and protect data at region, networking subnet, application tier, database. Even within a database, you can protect data at a row, column, or even item level. So you can have an item with a data key, you can have columns with a master key, or in the row with a silver key, and the whole database with an N gold key. So all these concepts of key hierarchy and envelope encryption, or different encryption algorithm concepts, are possible because you have a centralized key management solution, or you have developed one. So what is the key management? And so now that we know what key management is part of, why it's important, and what it does, is it really why people use it. Most likely, a lot of times, the key managers are actually required by compliance and industry regulations. So a lot of folks talk about having a key management solution, and they go out and purchase one, usually because the fact that they need one because of the industry they're in. If you're in medical or data records keeping for health records, you have HIPAA, and if you're processing payments or any kind of thing like that, you have more regulations from PCI, DSS kind of thing. Now, for key management operations, so what is a breakdown of a key manager or key management solution? What are you really getting, or what is a key manager? We understand how a key manager does things from a logical perspective, but from a component point of view, what is a key management is built of, or what is the core functions of a key manager? So, going more into that. The key managers basically starts with how a key manager is deployed, and from there how it basically creates keys. So first and foremost, what is a key management solution? What does it look like? What is it? Well, it can be a software-based solution that's deployed on an appliance or a server, or it could be more of a hardened server that has a physical device that's part of it, which is like an HSM. We'll talk about that in a bit. After the key management solution is deployed, you have the task of generating keys itself. And generation of keys or key material or secrets or however you like, it's not interchangeable, but generation of key material is not trivial. It requires you to have specific, pretty good random number generator or pseudo number random generator kind of function in it. And once you have implemented that, you can develop key material. And part of that developing key material sometimes also requires something called KDF, which is key derivation functions. So all of those functions regarding key generation or key derivation are part of a key manager, and they're one of the core functions. Part of another function of key management is to store keys, how to make sure the keys are stored in a secure manner with its integrity preserved, and then you are keeping track of the keys themselves if they are associated with some kind of application or they're associated with some kind of external entity. Some key managers do that. So the core component of a key manager and key storage is that confidentiality stored in a proof protected environment. And those are some of those things that are defined actually by FIPS. And I'm not going to get into it, but FIPS 140 standard-2 talks about levels for that, 1, 2, 4. And one of the core components of key management is to make sure that the keys themselves are in a container that has some kind of hard security standards around it. It either is a level 1 or level 1 where it can detect or not detect but log some kind of tamper activity, or even up to level 4 where it can just not only detect but it can also try to prevent any kind of tamper and be resistant to a tamper. So there's a lot of different level 1 to level 4. There's a lot of areas in there. Another function of key managers is key rotation. And part of key rotation is more like what crypto period and goes along with crypto period. And there's a whole FIPS NIST standard about that, how to determine what your crypto period or crypto rotation time should be. And that falls into maintenance of keys. So you can have a key manager that actually rotates keys for you, or you can have it, or you can go ahead and do it manually. But that is one of the features that core key managers have. Another part of key managers to have it talk about is how key managers associate with usage. So protection to ensure that keys are used correctly, and part of some key managers of associating with access of keys for encryption or decryption is that they are associated with things like what application they should be used, or some access control built into key managers. So certain application can access only certain keys. This will become quite clear when we get into the latter part of our discussion about hardening key managers. Associating of keys with specific key usage and key applications is a function that basically gets you the security you need, because at the end of the day, not every key in a key manager should be available to every application, and not every application should be able to access every key. And basic idea of any security functions are that you have to prove that you are doing something correctly. You can log it, you can monitor it, you can communicate that you are handling the material the way it should be done. So logging and monitoring of keys, and possibly doing it externally out of the key manager, having an export function or having a function that can notify about possible evidence of tamper and things like those become very important when you're multi-tenancy environment when we get to the cloud. Key management lifecycle, that's pretty much what I described, but there's an actual formal definition of key management lifecycle. It's defined by NIST, and I think it's part of 852, Part 1. And I won't talk about that here, but there is like 4 to 5 different key states, and if you guys are really interested about how key managers work, that's in there. Now, how does it, like I started this talk about the platforms and about key managers and how they're hosted and then how they're run. So you can run them on-prem, hosted. You can do the HSMs. You can buy specific devices to do that. You can virtualize them, or you can use cloud providers, including cloud-based HSMs. So not only you can get cloud-based software solutions, but you can get true cloud-based HSM. We'll see that in the latter slides. So I put a real-world example in here, and I put Home Depot because, ironically, they were also part of a data breach. But recently, I've been working on my bathroom, and I've been running to Home Depot quite a bit. So I always wondered, how they're actually doing their transactions and securing how they handle returns and how they handle payment transfers. So what they do is when I go there and I buy the wrong part for all the plumbing that I'm doing, I don't know, and then they run the transaction, and then the transaction pretty much gets request encryption key like we talked about before from a key manager that they probably have in their data center or possibly in the cloud. And then basically, at the end of the day, the transaction, the data key comes back to the point of sale POS thing, and then it probably encrypts it and sends it to the payment processing people or returns department back at the Home Depot, which possibly might be different, might be the same. And obviously, I go back to Home Depot to return stuff. So when I go back and I'm returning stuff, I pretty much what should be happening or could be happening as an architect is that the request of payment info, and it goes to returns, which requests the same key from the key manager, and the key manager gives them the key, which allows them to decrypt the data and comes back in plain text back to the return POS. So in this real-world example, it's kind of obvious the fact that what the benefits of a key manager are, where multi-departmental environment, you have a key manager that segregates key usage from key operators and key data. So you might have key departments that use the material, but it's not in their hands, it's kept out. And the keys themselves are centralized. Without this IT infrastructure for centralized, you will not be able to track the life cycle of a key. You cannot be able to restrict access, or you might not be able to meet regulations and standards for PCI for payments. How you're supposed to secure payments. So this was a real-world example of key management. So I think at this point, pretty much everybody should have an idea of what key management and what we're trying to do here. Then there is something called HSMs. They're pretty much a hardware device for crypto operations and key storage. So they're just they're an extension of software-based key managers, and they basically go ahead to next level, and they are physically hardened hardware devices, which might be at level 3 to level 4. Though not always true. Some of the cloud providers, and we'll talk about later in Azure thing or not level 3 truly. But the concept is that HSMs focus more on the key container and the storage of the key material itself. They want to make sure the data confidentiality is preserved when the data key material is in the HSM. They provide strong protection of keys within the storage. They have physical access protections to detect evidence of tamper. And sometimes what they have also is secret sharing, like Shamir, where they break down keys into multiple parts and they recover them later when the key is needed. That way, if a part of a HSM device or one of the HSM devices that is part of a cluster of HSM gets compromised, you don't lose all the key material. And similarly to not software-based key managers, they do have not more, but possibly more sophisticated audit and log trace functions. So let's talk about, now let's jump into a little bit of key and cloud. And so this slide is a little bit of kind of pushes the idea of why we still use key managers on premise. But obviously there's a lot of reasons for that too. So typically key management devices and software solutions are pretty much locked down into a building with physical access controls and things of that nature. But at the same time, this talk is, I should have started that, but uses graphic rendering workflows as a reference for a lot of the reasons why cloud computing is used, because for graphic rendering workflow, which is something that I've been working a lot, is fits very well the model of cloud computing where you have elasticity. So you can seamlessly scale out and use cloud resources when you need. So you have an orchestration tool specific for clouds, specifically for graphic rendering, which can essentially instantiate machines, push out graphic rendering jobs to the cloud nodes, pull back data from the storage, and put together the frames. It's something that happens quite a bit. It is one of the large use cases for compute in cloud, and part of the reasons is because a lot of CGI, a lot of graphics are being used for M&E, movie and entertainment industry, from regular commercials to full-length feature films being developed in using heavy CGI. Graphic rendering is kind of one of the larger and one of the more interesting use cases. So going back to why we're moving from on-premise to key management in the cloud. So as you are developing and scaling out applications, using on-premise key managers is viable, but at the same time, it's very restrictive. A lot of those key managers are air-gapped and isolated, and you can't leverage any kind of specific scale-out cloud features or functions that you would like to have. You losing the lack of scalability and mobile device. It's kind of like the reason why people are using the cloud. So, point being is, as the processing and the compute and the storage is moving to the cloud, there is a really good need for moving the key managers from air-gapped networks on the on-prem networks out to cloud. So when we talk about key management in the cloud, what does that mean, right? So we talked about key managers generally. We talked about what they mean as a solution, what they mean as a software entity. Well, cloud is a multi-tenancy environment natively, or not. So essentially, everything is shared. Your resources are shared. Your compute machines might be instantiated for your use today, and they might be instantiated for some other use or some other customer or client, or even your own workflow at a different time. So the key questions to consider when we talk about key management in the cloud is, how are the keys stored? Where are the keys stored? And who has access to those keys? And how are those keys used? So when we look at these questions, we can also look at back and what we want to log and audit and how we want to monitor it. So we want to make sure that we want to look at, we should have a capability in the key management in the cloud that can track every possible key usage, key storage, and key access. Now, when we talk about loosely about having cloud key managers, there's multiple models there. There's no specific about you have to use one key manager or one key management solution. So the obvious solution is or possible solution is to use your current key management solution from on-prem and move it out to the cloud. So if you have written a key management solution from scratch, I hope not, or if you have bought one, you can literally take that and host it in a cloud and secure it. You could take a cloud, what's called cloud vendor partner solution. So essentially, you're leveraging a solution by a cloud vendor cloud infrastructure vendor that they have looked at, ported over, validated that it works in their environment, and then you can use that as a possible solution. So those are like things like Tenable or SafeNet solutions that are out there that you can literally go out there, license on the cloud, and start using those today. Then you can also have a hybrid model where you can take the current partner solution or any other key manager you have and scale it out, and then have multiple copies of KMS or key manager. And in that way, you are scaling out, and you might have some sophistication of having mirroring or some kind of region-based key managers or splitting keys using Shamir or any kind of various different models. And the last and the focus of this particular talk is native key management service or cloud HSMs. So these services are what Google Cloud, Azure, and AWS offer as a product and as a product of their own. So here, they're essentially all three major vendors, or all vendors at this point, have a solution of their own, either licensed from somebody who has been in the industry for a while. For example, Azure uses Talus, and AWS uses SafeNet. So essentially, but they are their products. They are natively can be instantiated as a server, as HSMs in the cloud, and you pay per key, per usage, per access model. You don't have to license the actual software that's underneath it. You don't have to license the software that's developed by third party. You just are dealing with AWS. And the access model for the native key managers is different from if you were using third-party model or vendor. There is an API defined by AWS or the cloud vendor. They talk about how to access keys, how to protect keys, and essentially the access to those keys is through their CLI and their console or their SDKs is. So we will be talking about, when we talk about this talk, how to secure key managers in the cloud, we're talking about the native solutions that are offered by cloud vendors. So before I get to the next slide, so things like Key Vault by Azure or KMS, Key Management Service. So before we get to this slide, you might say, I don't need a key manager in the cloud because I use some kind of storage mechanism with some kind of client-side encryption with cloud storage. So why do I need key manager, right? Well, next couple of slides will show the fact that you already might be using a key manager transparently that is being employed underneath. And it might not be, you might not be dealing with the key manager directly, but the way you are using server-side encryption or client-side encryption for storage means that you are actually you already are touching key managers. So one thing you can do, I'm not sure why the slides are out of order, but what you can do is you can have your data in your local key management solution, your local on-prem, and then you can just use your key material and you can store it into shared storage, into some kind of cloud storage. Here you're not using any kind of encryption method, but you might actually have the encryption tool. I don't know if the mouse. I don't have a pointer, but your encryption tool or your encryption data storage might be an instantiation of an EC2 machine or some kind of storage in the cloud. Another possibility is that you have your key material that is actually instantiated in an EC2 machine, or not EC2, but a virtual machine on the cloud, and then you're encrypting the data locally, but you're keeping the keys in the cloud. But in that regard, what's really happening is that the keys that you're storing is technically, you have a key manager in the cloud. So even with a client-side encryption, you are possibly using key managers in the cloud because you have instantiated a soft key manager on one of the virtual machines. When you talk about server-side encryption, which is more a lot of times people use to transparently store data in the cloud and multi-tenancy environments, they think that most people don't think about key management, but there's a major component of key management going on. And the idea is that you have your data go into some kind of web server with some symmetric key, and that plain text then gets encrypted with the symmetric key, and then that encrypted data gets stored into the data storage. Now, the symmetric key might be also was generated from your local storage or possibly from a key manager in the cloud, but it gets encrypted by a data master key in the cloud, and that master key in most server-side encryption storage workflows is actually stored in their native key managers. So when you're using AWS or you're using Azure to do server-side encryption for data storage, in essence, what's going on is you are actually using the key managers because the master key that's stored for those data keys is in the same key managers. You might not be paying for that directly. You might not be charged for those, but underneath the hood, there is a key manager involved, and that's being used. So I think we have 20 more minutes. But when we get to the key managers in the cloud our key management service in the cloud are very kind of similar to the key management on-prem, where you have things associated with usage of access and accounts and some kind of roles and users and things of those nature. So I'm going to skip this for a little bit of time and get to the next slide. So cloud key managers, you have developers, you have vendors, you have CSOs, and I think I will skip this slide just to get to the main part. So in the same thing, in the way it works is that you have in the key manager you would request the key data goes back, and then you encrypt your files and you put it back into some kind of shared storage, and then you decrypt it. You can also use disk encryption methods for cloud key management. So what happens here is that if you have a BitLocker, or if you have some kind of Linux machine with TrueEncrypt, or you can set up your cloud key managers to deliver the key material at boot up using some kind of APIs or built-in functions. So this is very popular when you have not EC2, but virtual machines or physical machines that you are renting out in AWS or any kind of any kind of cloud provider. And this is a different use case for volume storage. So let's talk about the core part of what we're here for. Let's talk about how we should secure cloud key management, and what are the hardening steps that you could take to harden a key manager that you might be using in cloud. So first, separate out your key managers. If you're using multiple clients, multiple workflows, or possibly multiple workloads, in AWS, I don't want to go specific, but if you are going to have one key manager for all of that, reconsider that. Consider having multiple separate key managers in multiple different regions, possibly multiple different accounts or subscriptions. So words accounts and subscriptions is interchangeable depending on the vendor you're talking about. But that kind of segregation between key managers is one way to achieve some kind of physical, not possibly physical, but definitely logical separation of key data. For us, when we talk about in terms of rendering nodes or graphic rendering, we suggest, and we suggest that if you are going to have content from multiple vendors, you definitely should be using multiple different accounts and keeping the different key managers separate for each high value assets. So if you're going to have multiple films you're producing or some things like that, you want to make sure that those volumes are protected by key managers that are not on the same account. In case of key manager account, or in case an AWS, or in case a cloud provider account is compromised, you want to minimize the level of breach because you have multiple accounts or multiple key managers. Next thing, segregate data and key secret owners. So the idea is, I did go through this slide a little bit, previous slide a little bit quickly for the time, but you have there is a definition of management and data planes. Idea is that you have people in the management plane who are managing the actual key vault of the key managers or key management. So they are defining, they're instantiating and adding keys. They are defining and instantiating key vaults in the cloud. And then there's a people who are on the data plane who are actually using the key vaults to unwrap, decrypt, encrypt, or rewrap, and those kind of functions using the key map. The idea is to essentially, you would like to segregate access and segregate user responsibilities for data management, for management and data planes. So the way you could do that is having role-based security methods or tying it back to your directory service or some kind of IAM user accounts or things like that. But generally speaking, it is a good set of practice and hardening guide to separate out the management plane from your data plane. Define specific roles for KMS. So when we looked at different cloud providers and then looked at the native solutions, built-in roles are not sufficient. They don't have logical roles that map very well to real world. And I think there's another slide later down the road that talks about specifically a use case where if you don't define roles, if you don't define key roles or define key users, all the keys that you create get assigned to the root account, and essentially you have all your key material under one account, and possibly one credential could be breached, and all the key material can be compromised. So what we're trying to say is that use role-based security, role-based access control, and define specific roles of key usage and key management for your workflows. And in those cases, you should have at least 3 different roles. You should have a role for your security team, which handles the actual key management in the management plane. You have your development operators. If you have a third-party applications that are handling your keys or accessing your keys, or if you have your own applications that are going to be accessing or storing keys, you should have accounts for those. And then you should have separate accounts for people on the compliance side and auditing side. Another thing to consider is when you talk about access of management and data planes, there should be different access endpoints. Try to secure those endpoints, and they shouldn't be through the same access. They should not be through the same access point. So, for example, if you have a large data plane and you have a lot of applications coming to your key manager, that's okay. But if you want to, you should lock down your management plane to a Bastion server on that you can only get through VPN into your VNets or VPCs. And that way, you are ensuring that your access points to getting to your key manager are through different entry points. Another thing that we another concept to consider is having key permissions for key access at key levels rather than having wholesale master keys or key vaults or key managers. Think about having key permissions and access control at each key level. Now, that might sound a little too restrictive, but in case you want to revoke access to a certain key or certain application, you want to revoke access of a certain application to data, this will help you having that granular access that you need to manage storage access. Now, if this goes back to the key hierarchy that we started out in the beginning of our talk. That if you have if you have keys to you have access to keys at a very granular level, you can actually set up that your rows or your database, your regions or your subnets or your workflows or your clients, however you logically like to create components, you can set up access at that level. Another thing that you should consider is multi-party controls. An idea over here is that if you are going to have high-value assets that are stored and that are protected by keys, use multiple signatures on API calls to protect those access to those keys. So in that manner, a single if it's, for example, unreleased film content that you do not want to release before its release date, you would like to have multiple people, multiple signatures attached to that API call before that data you have access to those keys. So this is possible in multiple cloud environments. Do not use default key policies. For example, like I said before, most used key policies allow that one user to access all keys. And specifically, I think AWS does this. So if you have no key policy defined, it would create one for you by default, and for every time you instantiate a key, and the access to that key is automatically assigned to the principal, which is a root account. So essentially, all keys that you don't define a policy for are under the root control, which itself is against what most cloud providers say, that you should lock down the root account. Another method you can use to protect keys or gain finer access to key management data is that if you have a key, essentially what happens is that if you have a key use policy defined for a key manager, when you instantiate a key, the principal gets access to the full key itself, meaning that they can actually do puts and gets and through the REST API functions. Well, what if you don't want that? What if you only wanted certain level of API functions to work on a key? Well, in that to achieve that, you should be, and I think generally, once a key use policy is defined as a single principal, that principal should grant out access to those keys rather than that principal itself being used for key access. This will achieve the fact that most key material cannot be changed by one single principal, and then you can achieve finer control over the key operations. We talked about role-based security access controls before, so use IAM, use directory service, whatever your flavor of cloud provider is. Set up a directory service locally, or set up some kind of your own authentication server, but define specific roles for key usage. Audit all key management activity. So we recommend that you enable logging of key managers in subscriptions in Azure, for example, or specifically, we also think that all key management data, log data, should be logged external to the key manager. So not only the key management data is logged into a subscription or account, but it should be ported out or stored externally to an on-prem, preferably, or it should be stored out at least in a different account, even in cloud. And if you are going to use some kind of analytic tools, and you should try to use those analytics tools outside of that cloud. Like if you're using CloudTrail or I'm not sure what Azure uses, but if any of those products, try to specifically use them outside of one analytics account, outside of the main account that the key management is being logged into. Multiple key managers have automatic key rotations. It is recommended that key management is automated. Key rotation is automated to a certain crypto period. I put 60 days in here. 90 days is, I think, is the standard defined by NIST. But at the end of the day, the time period, the 60 days, is specific to how the keys are used in your workflow. So it is important to do an analysis of key usage and understand at what level of key value, what's the value of the data, and understand how long it's going to be used and be serviced, and figure out a crypto period, and enable the automatic key rotation. And one of the last ones, I guess, is the remove key policy, metadata, access control when key material is destroyed. So if, and this happens, then you remove a key from a key manager. If specific accounts are created, specific metadata is created, specific access controls were set up for specific users or applications, they should be orchestrated to removed automatically or by hand when a key material is used. So keep track of the resources that were actually instantiated just for the specific keys, because keys themselves have a defined life cycle, and keys most likely will go and expire, and at that time, if not associated correctly with some kind of resource group or tagging or some of those functions that are built into the platform, it's possible that some users or some application access stays active even when the actual key that was the actual resource that it was assigned to use has expired or suspended or destroyed. So in the real world, we basically did Microsoft Azure reference architecture, and we talk about in this specific case how to scale out, how to go from your on-prem and expand out to the cloud seamlessly, or not seamlessly, but in a way that you're computing or doing some kind of graphic rendering or whatever your flavor of compute is or whatever your function is. And but in this particular scenario, we're looking at graphic rendering. So if you're doing graphic rendering and you need extra 15 machines because you can save time and you're on deadline, how do you set up that? How do you set up those reference architectures? What is those? So on the left-hand side, on the right-hand side, I guess it depends how you look at it. But on the left-hand side, you have your on-prem network with some subnets. You have your compute farm. You have your Active Directory services, things of that nature, and your logging servers. You set up a gateway. You set up gray zones in the middle for ingestion and ingestion of data. You set up DMZs. You set up a Bastion server and manage. So a Bastion server for management of resources like Key Manager. So that way, the only way you can access Key Managers or Active Directory device machines on that Azure network is through that Bastion server. And then having those red zones, like zones for red, gray, and white zones, is pretty important, because now you have a gray zone that has all your appliances. You has all your network appliances or your firewalls. And in AWS world, that's security groups because they're stateful firewalls. But regardless, the point being made is that essentially protect your appliances for your network access into gray zones. Have Bastion servers for access to your resources like Key Managers. Put your compute and storage farms underneath and behind the gray zones, and from there you can instantiate gateways and gateways and appliances to get to your compute nodes and those subnets. We only have 2 minutes left, so I'll just jump to the next slide. This is a holistic list of approach of Azure security controls. So we developed a whole bunch of security controls to secure an Azure environment, including the portal, the networking, the command line, the compute, the storage, the batch, the role-based access, every part of what Azure offers. We're looked at it, and we have come up with a hardening guide for that. We only have 1 minute, so we'll jump to the next slide quickly. As a control wall, things, like I said, use Active Directory to have RBAC, segregate data and key owners, using directory services, manage access to secrets on key level pairs, rotate keys using automation, audit all activities, restrict access to key vault using network security groups and things like that. And finally, we have AWS reference architecture, which is a little different, but the idea is that similarly that you have your regions. I'm not sure if you have your regions, you have your different subnets, and you want to make sure that the access to the keys and access to Key Manager is through some kind of DMZ zone, and it's not it's in the bottom right hand, in the bottom part. You can see that the key managers devices themselves, the key vault, the KMS, are region wide, so they're accessible to all VPCs. So you want to make sure that those access to the KMS is only accessible to certain VPCs through using SGs, which are security groups, and you lock those down, and then you use protection. This is a larger architecture. It talks about all the features, but you want to make sure that you don't put network gateways on internal subnets and things of that kind of thing, things like that. And then you have your on-prem network extending out to the AWS using some kind of VPN devices. And here, if you're using one of the recommendations that we see and we make all the time is that if you are going to use some kind of direct connect device or direct connect fiber link between your on-prem to your AWS nodes, that doesn't mean that that direct connect is protected. It's private, but it's not protected. So we make a recommendation of using VPNs and using separate VPN, and not only using VPNs, but using multiple VPNs on the same direct connect to segregate things like workflows and clients and workloads. So if you have multiple clients working on the same AWS cloud, you could have one single direct connect kind of thing and with dedicated fiber, and then you have multiple instantiations of VPNs that end at different endpoints in the AWS cloud. Similarly, if you had things like key managers in the cloud, you can set up a separate VPN for it so that it only ends in an endpoint for management plane, and you have a management plane that ends in, you have VPNs that only end in the data plane side. I guess this is the end. So any questions? I'll take questions. We have 4:22, so there's 50 minutes talk. So I guess at the end of the day, it all comes down to what usability and security you want. So locking down of things is very subjective. Locking down and hardening of appliances and locking down of workflows and how much you want to apply is specific to business needs and how much effort and work put into to create policies and actual implementations and going through all the switches and routers and configurations is something that you have to determine, because at the end of the day, you still have to get your job done. That's all I have for today, but I can take questions afterwards, or I don't know how long we have the room, but.